So my name is Amikam Bar-gil, and I'm the CTO and one of the co-founders of Yemoja. Yemoja is trying to nourish people with sustainable microalgae. Now, what is a microalgae? Microalgae is a unicellular light-driven organism, meaning that it utilizes light and carbon dioxide in order to assimilate carbon dioxide to sugars, and then to thrive and to multiply and to create, synthesize actually, numerous biomolecules. Almost each year, the science is discovering up to 1,000 novel molecules that are extracted from microalgae, which is presenting a huge potential for humankind. It is microalgae and cyanobacteria are responsible for more than 50% of the oxygen that we are breathing. Actually, it's a little bit closer to 70%. It has an enormous biodiversity, more than 500,000 strains of microalgae out there. Cannabis is only one plant. The microalgae world and market is relatively small because of a few problems that we will talk about in the following slides. Now, it should reach 4.7 billion by 2026. The global plant-based protein market is expected to reach 7.5 billion by 2025, which is comprised of both algae, microalgae, soy, and everything else. And the algae takes part in the food and beverage segment, is expected to reach 1.1 billion in 2026. It's currently standing around 0.8. It's not a lot, but the problems is not that the microalgae has no potential when we talk about the ingredients. The problems were the cultivation system. Now, as you can see in the middle picture, you can see one of the most used systems for microalgae cultivation. It's an open pond. It is exposed to the environment. It is totally dependent on the environment. And thus it gives you a little bit control, almost nothing, and gives you a big headache when we talk about reliability, especially in quality and consistency. And other companies that want to use the ingredients from these microalgae cannot rely on it, and it gives you an unstable supply chain. And now, Yemoja thought a little bit different. We combined some of the knowledge that came from the fermentation world and the other knowledge that came from the microalgae universe. Now you can see in this picture how it really looks like. These small vessels are one column. Each column is separated from the other columns, meaning it does not affect the other 800 columns which are here. Each one of them is completely isolated, and the whole system itself is located within an indoor environment, meaning that each and every parameter of the environment is being controlled and monitored 24 hours a day, each and every second, with full feedback from the computer. If the light needs to be adjusted, light spectrum, like intensity, salinity, adding nitrogen, or adding any other ingredient that the culture needs, computer knows exactly when, where, and how much. And this is something that we took from the fermentation world. Now, this is just a sketch of the system that we have in Tel Chai. It's one column of 25 liters. 4 of them are located around an LED-based light source. We just multiply it by 10, and then by 2, and then by hopefully infinite numbers, meaning that we didn't increase the size of the vessel, we just multiplied it. Instead of going from 1 unit of 100 liters, fermenter of 100 liters, reaching up to 100,000 liters, like you guys are doing, we stayed with 25 liters because the size and the volume really matters when we talk about microalgae. Each and every increase of the volume is a totally different environmental niche because of light penetration, diffusion of gases, and everything else. We needed to stay with the optimal size of our vessel. Now, let's talk a little bit about protein. As we know, by 2050, the world population will reach 9 billion, and we need to feed them all, at least part of it. Now, if you want to feed them with dairy, we are polluting the environment with 9.5 kilograms of CO2 for 100 grams of protein. And if we're going down to fermentation, we see that it's really, really good and clean because only 150 grams of CO2 are emitted from, for each and every 100 grams of protein produced by fermentation. But if we're talking about microalgae, we see that we are negative footprint, meaning that we are taking 400 grams of carbon dioxide for each 100 grams of protein produced by microalgae. Now this is what we currently do. We have 1 ingredient for food, 2 ingredients for cosmetics, and 2 ingredients for healthcare. And lately we launched the first ingredients for food, which we call onye. Onye is a blood substitute. It mimics exactly the behavior of blood. When we talk about changes of colors to temperatures, it gives you taste of blood because of high iron concentration, contains high concentration of vitamin B12, protein, essential fatty acids, and above all, it gives you a nice little bleeding effect that you can see here in the veggie burger on the right corner side of the picture. Now, I'm not sure I have more time. No, this is us. This is the team. I was Amikam, and this is Yemoja. Thank you very much. Questions?